Welcome all, welcome to this lecture of Object-Oriented Programming 1. Today we will be continuing with Unit 4. In last session we started with Unit 4, Objects and Classes. So let's see some more things about objects and classes. Okay, let me show the disclaimer first, then I will start the session. Okay, so uh, let's start the session now. Okay, and so last time we saw, okay, before we start, let me show you what is basically, see, the features of Java, okay, that we know is that it is very simple, right? It inherits the syntax of C and C++, so it's very, very easy to learn. Those who have learned C or C++, they can easily learn Java, right? And then basically it is also secure. It provides a kind of firewall between your application and the computer. How? Because it provides you a JVM inside which your program runs, right? So there is a Java runtime environment in which your program runs. So, and also if you are using web browsers or web-based applications, then Java compatible web browsers are being used. So you can, safely run the Java programs. Third, it is portable. It is not dependent on any operating system. It is compile once, run anytime, anywhere kind of thing. So you compile on one machine, it can run. If you compile a Java program on one machine, and when you have a class file with you, you can run it on any machine. Okay, that is what it is, portable. Okay, and it is object oriented. Everything is an object. Everything is considered inside class only. All the code is mostly inside the class only. Okay, and it is robust. It has got good memory management, automatic garbage collection is there, and also good exceptional handling. There is runtime errors checking is also there. So these are some of the features, and out of these we will be focusing more now on object oriented feature. Okay. It is also multi-threaded. Okay, allows you to write programs that can do many things simultaneously. Okay, again it is architectural neutral, that is write once, run anywhere, anytime, forever kind of thing. It's almost similar to saying it is platform independent. Even if the operating system upgrades or process upgrades, it will not affect. That's the best part. It is interpreted and high performance. Normally interpreted languages run slow as compared to compiled languages, but it is still giving high performance, right? It has got just-in-time compiler also. Okay, so what happens is bytecode is being, once the Java file compiles, you get a bytecode, that is class file. So it is designed in such a way that it is easy to translate directly into native machine code, okay, to get high performance. Okay, and how is it done? With the help of a just-in-time compiler. Okay, it is distributed. You can use remote method invocation. Remote method invocation is like there are two machines, okay, and you are using an object on this particular machine, and let's say the code for that object is on some other machine. Okay, the code is on some other machine. So you invoke a method over here, and that will invoke the method remotely on another machine. Okay, that is called as remote method invocation. Okay, and other distributed features are also there in Java. It is dynamic. Okay, small fragments of bytecode may be dynamically updated on a running system. So these are some of the features of Java. Which is why Java is popular. And the best part is that it is totally object oriented language. Why? Because everything is inside the class. Okay. RMI. Okay, Jayshankar wants to know what is RMI. No problem. So see, Jayshankar, when you will start learning advanced Java, in that advanced Java subject, you will basically go deep into remote method invocation. But it is something like this, where a client machine is there, okay, and there is another, some other server machine on some other client machine, we can say, right? Normally, it is a server machine. So if you are running a program over here, okay, if suppose you are running a program over here and you are using a class inside it, right, or an object inside it, what is this? This is suppose an object, and basically the object, actual object, resides on the other side of the, you know this is actual object, let's suppose, which is on the server. So in between there is what? In between there is network, right? So when you invoke an method on this object, that will invoke the method on the actual object, okay, on the server through network. Okay, so this is called as a remote method invocation, and then the control would return back to this program through the network. Okay, so this kind of facility is called as what? Remote method invocation, where you have an object on the client side, but that is not an actual object, just a representation of the original, which is on the server. Okay, so this helps, in distributed programming a lot. Okay, is it out clear, Jayshankar? Yes. Okay, good. Fine. So these are some of the features of Java. Okay, and uh, if we see which are the object-oriented programming principles that Java follows, are these. See, so the first one and the first for most important is the class. Class is nothing but a blueprint or a template for object. Okay, what is it? It's a blueprint or template for the object. Okay, so depending on that blueprint, the object will be structured. Okay, what is object? It's an instance of the class, or it is nothing but it represents the real world entity, or it's a real time entity. Okay. Okay. Now there are some other concepts also in object-oriented programming that you will learn, especially concepts like encapsulation, okay, inheritance, polymorphism, and abstraction. These four can be also called as the pillars of object-oriented programming. Okay, can be also called as the pillars of object-oriented programming. Okay. Encapsulation is wrapping up of data, or we can also say data hiding. Data and functions are wrapped into a single unit, that is a class. Okay, a class is the best example of encapsulation. And inheritance is there, where it's a process by which objects of one class get the properties of another class. So if you have a class that, let's suppose this is parent class, right, and you inherit from it, extend the from it, so you get what? You get a child class. So suppose parent has got, let's say, 3 properties, and these are publicly available. Okay, these properties are publicly available. So when child class inherits from parent class, and let's suppose child class has also got its own 2 properties. Okay, it has got its own 2 properties. So what happens is child class also gets the parent class properties, since these are publicly available. Okay, and it has got, so it in all it gets how many? it gets 5 properties. 3 from parent class and 2 from its own, so total 5 properties. So this process or this thing is called as inheritance. This thing is called as inheriting the properties of parent class. Okay. Then you have got polymorphism, which is an ability to take more than one forms. Okay. So when you have a method with different names, that is method polymorphism. Okay. We have seen an example of that before. We'll see again in the future also. And there is abstraction. What is abstraction? It is nothing but, you know, the way to represent something or some essential features without including the background details or explanation. Okay. So abstracting real world entities is the process called abstraction. Okay. Abstracting the real world entities into software entities. Okay. So if you say that you are making a class of real world entity car, but it doesn't mean this is a physical car, right? And you can design your own car depending on the properties that you put, right? So it is, this decision has to be taken by the designer of this class, what properties he will put in this car class, right? So he can abstract that car object as per his, you know, need. That is called as abstraction. So these are some of the object-oriented programming principles. When you start, you know, practicing all those things, the classes and objects and all those things, these all 4 will become much more clearer to you. If you are right now not able to understand it, don't worry. Okay. Okay. So how do we define classes for objects? Basically, a class defines the properties and behaviors. We saw it last time, right? Class defines what? 2 things are there: properties and behaviors. Okay. Now, what are properties? Properties are also called as the attributes. These are also called as what? Variables, or simply instance variables. Instance variables that belong to the instance, not to the class. Okay, remember there are 2 types of variables: class variables and instance variables. So instance variables are those which belong to an object, not to the class. Okay. Or it has also called as properties. Attributes, properties, or also data field. Some even call it as data field. Okay. And what about behaviors? Yes. What about behaviors? We just saw what are properties. Now we see what are behaviors. So basically, behaviors are nothing but the methods that are, or we can even, some people even call it as operations. Okay. Behavior of an object is nothing but a method or the operation for the object. Okay. Now, object-oriented programming always involves programming that revolves around objects, that focuses more on objects. That is the center point. Okay. So an object represents what? Object represents an entity of the real world that can be distinctly identified. Okay. So we saw last time that what is an object? Object can be a real world entity. For example, a circle object or a rectangle object. These are all shape type of objects. What are these? These are all shape type of objects, right? So every object has got 2 things: property or an attribute, and the behavior, that is action, which is defined by methods. So the property or attribute is defined by data fields, or simply the variables, and action is defined simply by methods. Okay. So circle, for example, if you are taking circle object, then the data field may be radius. If you are taking a rectangle object, then the data field may be width and height. And if you are considering so this was state of the object. Okay, this was state of the object. So for example, there might be a circle, that is having let's say a radius of about 5, right? And there might be another circle, that would be having, let's say, the radius of about 10. Okay, so both the circle objects are different objects. Why? Because this has got a different radius, or we can say simply say this object has got a different state. What is state? The state is that the radius is 5. So accordingly, the area will be calculated. Accordingly, the perimeter will be calculated. Similarly, this circle has got radius 10. So obviously, its area is different, its perimeter is different. Okay, so that's why this state of this circle is different. It might even happen that you might, you might make a same circle object into different states, or even you may take the object into different states. For example, you say circle C equal to new circle. Okay, circle C is equal to new circle, right? Here you create a circle object. Now suppose you say C dot radius, okay, is equal to 5. So at this point, the radius of the circle is 5. So the circle is in this state, we can assume. Now when we say that C dot radius is equal to 10, now the circle has gone into a different state, and we can assume that it is this particular state. Okay, so the state of the circle may change depending on the property that the circle has got. What is the property? The radius property. Okay, the data field is radius. Similarly is the case with the rectangle. Okay, similarly there is a case with the rectangle. If you have a rectangle, this is suppose one rectangle, and it has got, let's say, width equal to 30 and height equal to 10, right? And then you might have a different rectangle where the width might be equal to 60, okay, and height might be equal to 30, right? So it might happen that these two are different objects or the same object in different times. This, let's say when you created the rectangle object, this was the state of the rectangle, and then you just altered its state. By meaning of that, what do we mean by saying that we alter the state? What does it mean? It means that we alter the width and height. We change the width and height. We change the height to 30 and we change the width to 60. So the object now is in this state. We can say that. Understand? This is what you have to assume. See, by making a circle object, you don't create a circle diagram. By making a rectangle object, you are not creating a rectangle diagram. This is for your visualization I am drawing here. Understand? For your visualization only I am drawing. You have to visualize the objects. If you know, I would recommend you people that if you want to learn Java easily, then start visualizing the objects. Whatever objects that you are programming, start to visualize with the objects and start modifying the objects, and start testing your objects so that you can play with your objects. In this way you can start playing with your objects. Okay, so once you start playing with the object and visualizing your object, you will be easily able to work with Java programming language. Okay, so that was about state of an object. Like for example, circle would have a radius field which would define its state. Rectangle would have a width and height field which would define its state. Similarly, there is a method that is nothing but the behavior of the object. So there can be circle can have set radius, get area, get parameter, those kind of methods. Okay, and additionally, a class provides a special type of method that is called as the constructor. This is very, very important. This constructor helps you define what will be the state of the object when it is initially created. When the first time object is created, what will be its state? That is defined with the help of constructor. Okay, so if you define a parameterized constructor, then you could have even, you could define something like this. When you say circle C equal to new circle, right? Here you are not passing anything. I'm not saying that I want the radius to be something like this or what. But if you, make parameterized constructor, then you can specifically say something like this. Circle C is equal to new circle. And in bracket, you pass some value. Let's say I want the radius to be 10. So you pass the value of the radius. And this value 10 will be passed to the constructor. And in constructor, you will have put the code that will assign this value 10 to the what? To the radius. To the radius. Okay. So these kind of things, for initializing the objects while creating it only, you use constructors, right? So for example, this is something saying this. When I say int I is equal to 10, what am I doing? I am initializing it with some value when I am declaring it. Okay, I am initializing it to with value 10 while I am declaring it. There is another method also. You declare it and then you initialize it. Okay, so these are two different things. This is declaration statement and this is assignment statement. Or if it is first time, then the assignment statement is called as initialization statement. But here the declaration and initialization both happen together. Okay, so similarly, if you are creating a circle like this, you are only just creating an empty object, circle empty object, right? But if you are creating like this, you are even initializing it with some value, by some default value for its variables. Okay, so for these kind of things, constructors are very, very useful. Okay, so a constructor can perform any action, but constructors are designed to perform only initializing actions. It's better to use initializing actions. What are initializing actions? Initializing actions are nothing but to set some values of your data fields, right? So for example, you might want to create a rectangle with a specific width and specific height. Then you might use constructors where you can pass width and height, and that would be assigned to its data fields. And okay, so let me show you how that happens. Let us go to let me show the code, and that you will easily understand how that thing happens. Okay. Okay, there are some chat that what is the changeable properties or behavior of object. Okay, just a minute, Jayshankar. Let me show you the code. Then you will be able to understand what is the property and what is the behavior. Okay. Okay, so in this unit 4, we had made this test circle last time, right? We made a circle class and we made a test circle class to test that circle. The circle class had got a property called the radius, right? And it has got what methods, specifically get area method, then get parameter method, and then set radius method, right? So these three methods basically belong to the circle class. Now you are defining the radius as 1. So every time you create a circle object, by default the radius is always 1. Then you can set a new radius, right? So what if you want to create the circle object with a specific radius? Check this out. Here I am saying C1 equal to new circle. I am setting the new radius, right? And before setting the new radius, if I don't set this radius, if I just comment this out, and if I run this program, it will give me the area and parameter according to this radius. Understand? which is by default assigned. So check this out. The circle area is this and the parameter is this. Okay. I run it again. This is the circle area and this is parameter. So this is the value of pi, right? Radius is 1, so radius square is also 1. So this is the value of pi that you get over here as the area. Okay. So now, what if we want to make the circle object, we want to give the radius while we create the object itself. And we don't want to set it separately. So there is a constructor available. So see, these are normal methods. Okay. These three are regular methods or simply methods. These are called as simple. But there are special types of methods. Those are called as constructors. And constructors have the same name as the class name and do not return anything. These are the two basic things that you have to make sure about the constructor. So the constructor, if you create a constructor for the circle, it will also be named as what? It will also be named as circle. The only thing is that it will have a bracket around it. So this is a simple constructor where you can do some code. Okay. And there is another constructor called as parameterized constructor also, where you can pass some parameter to it. So let's say we pass some parameter over here, double D, and then in this code, and then in the code, what you do is you assign that D to the radius. So whatever you pass to this double D gets assigned to this radius. Understand? So this is a no argument constructor. What is this? This is a no argument constructor, and this is a specifically parameterized constructor. Okay, understand? This is a no argument constructor or default constructor. It is also called as what? It is also called as default constructor. Okay, this is nothing but the default constructor, and this is parameterized constructor. So what we'll do is, okay, one more thing about default constructor. Default constructor is automatically given by the compiler. So see, you might have seen this, that here in this circle class we have not yet provided a default constructor like this, saying circle, the name of the class, empty brackets, and any code, some code, right? We have not given that part. Still, when you say circle C1 equal to new circle, this statement runs properly. Why? Because when this class goes for compilation, when it is compiled, right, at that time the compiler inserts this code itself over here automatically, if you don't have a if you don't have a default constructor. If you have a default constructor, then it does not need to enter it. If you don't have, then it will enter. Okay. And if you have, suppose, a parameterized constructor over here, then this will not be inserted by the compiler. If you already have one compiler, one constructor, compiler doesn't, take care to insert one more. Okay. So see, still this, we can see that this thing is working. Why? Because compiler inserts a empty constructor. It's an empty constructor. Okay, no argument and an empty constructor, right? If we even want to, add it, we can add it like this: circle and brackets, and inside that do something. That's it. So what you can do is you can assign this radius equal to 1 over here. So let's don't assign 1 over here. Okay. So if if you invoke this kind of code, then that radius will be automatically 1. And what if you want parameterized constructor? Then you see, if you give this repeat this code, then it gives us error. But now I'll take a variable over here saying double d. This circle constructor will receive a double variable, and that double variable will be assigned to what? That double variable will be assigned to radius. Okay, so now see, you can see there is a difference between both of these codes. Yes, do you see the difference? Tell me, what difference do you see? The difference is circle. If you use the code like this, circle C1 equal to new, this will take more lot of space, I'll reduce the size. Circle C1 equal to new circle. So this will create a circle. This will invoke, this new circle will invoke this particular constructor. Okay, and suppose if you say circle C2 equal to new circle, and here you pass 10. Let's say it is an integer only, or let's pass an, let's say 10.5. That's our double value, right? So what happens is this code will invoke this constructor. Which constructor? This constructor. Okay, so there is a difference. This is called what? This is no argument constructor, and if you take this, then this is what? This is parameterized constructor. Understand the difference between both? Okay, now you will ask, sir, what if we don't give any of this constructor? Then obviously I told you that the compiler will add this kind of constructor, but it will not have this code. It will be an empty constructor. It will be no argument. No argument means it does not accept any argument over here. In this brackets, you cannot see any argument. You cannot pass any parameter or any argument. Okay, so it is called as no argument constructor. But here you can pass one argument. Here in this circle, you can pass an argument, and or we can simply say you can pass a parameter. So that's why it is called as parameterized constructor. Okay, understand the difference between both? Yes. What is a no argument and default constructor, and what is a parameterized constructor? Okay, so now see, now we have defined that if we use this code, then that circle will be having radius 1, and if we use some code like this, circle C2 equal to new circle 10.5. now this will be having what? The radius of 10.5. so see what happens. Now I'm not setting the radius over here, and we will simply get the parameter, sorry, the area of both. So circle 1 area is C1 dot get area, and here then we'll say circle 2 area is C2 dot get area. Let's run this. You see this? Check this out. I run this and I get to see what? Circle 1 area is this, and this is circle 2 area. You can see the vast difference between the area. This is a very, very small circle, you can see from the area, and this is a very big circle. Okay, understand? Okay, so this circle was by default having. So what happens? Let me show you what happens. Basically, when we specifically run this particular statement. When this statement is executed, okay, it does something like this. Check this out. I'll take this to here. That is not an issue. Okay. Okay. So now we will be easily able to understand this, what is happening. Okay. Okay, check this out now. So in this circle class, we have got these two constructors, right? We have got these two constructors. Now when we say new, this line number 26 is executed. When we basically run this command, Java and test circle. So what happens is this main method is invoked, okay, and the first statement executed is this one, which says create a new circle. So from here the control will go over here. It will say, okay, we have to set the radius equal to 1, and then a new object will be created. This will create a new object. Okay, this will create a new object, circle object, which has got what? Which has got radius equal to what? 1. And which is pointed by whom? It is pointed by C1 reference variable. Okay. So this object is now pointed by C1 reference variable. Similarly, when you execute this statement, the control goes to this particular constructor. It will create first. It will create the circle object. Okay. Let's have the same size of object. Okay. And here it will have what? It will have radius equal to 10.5. Will be having radius equal to 10.5, and let's call it as this is the circle object 2, and this is circle object 1. Okay, and it will be pointed by whom? By C2. So C2 will be pointing to this particular circle object 2. Okay, so what happens is when we execute these two commands, these two objects are being created, where these two objects are, as we talked about in last session, we have talked that there is something called as object, what? Object heap. The circle objects are created on object heap. Okay, just to understand these are object, I am giving them rectangles, a notation of rectangle, but don't worry, it is a simple object. It's a physical object, and it is not even a shape object. It is just a software object, right? For us, it is a circle shape. How? Because we have given it some radius part. We can define any property. Okay, we can define our own shape having its own properties. Understand? That's the power of object-oriented programming. And so see what happens when we execute these two statements. The objects are being created on the heap, and these two variables are available on stack. These two variables are available on stack. Stack of what? Stack of main method, since these two are declared inside main method. Okay, these two are what? These two are reference variables, which are available in the stack of the main method. Okay. And now since the objects have been created, when you say c1.getArea, the area will be calculated as per this radius 1. So that's why you see the radius of this circle object is 1, the radius of this circle object is 10.5. So both the objects are separate objects, physically different objects. What the objects are? Physically different objects. One object is having radius 1, so its state is different than the state of this object. So when we say c1.getArea, we get a different area, and when we say c2.getArea, we get some different area. Understand? Both of these are different areas. And now what happens, suppose I say, what happens if you do something like this? C1 is equal to C2. So now you want the C1 to point to C2. So what will happen is, a new link will be generated from C1 over here, and C1 will be pointing to the object that is pointed by C2, and this link gets lost. This link gets lost. So now this object is not being pointed by any reference variable. Okay. This object is not being pointed by any reference variable now. So this object is now, it's possible to do garbage collect. It's possible to garbage collect this object. To do what? To do garbage collection of this particular object. Okay. So this garbage collection thread will automatically generate, and it will garbage collect this thread. So what does it mean by garbage collection? To free the memory, to free the object heap from this object. So it will destroy this particular object. Okay. So this is what happens when you are accessing objects. Objects are created on objects heaps. These are pointed by the reference variables, and reference variables point to different objects. You can change those reference variables to point to some other objects. Okay. And you can assign the properties of objects with some values which will define the state of that object. Okay. So this is about what? This is about objects. And objects have what? Objects have got properties and methods, or simply the properties and behavior, or state and behavior. So see, this circle has got a different state, this circle has got a different state, right? But the behavior will be same. Which behavior? When you say get area, okay, when you say c1.getArea, the area will be calculated as per this instruction only, as per this this evaluation only. As per this statement only, the area will be calculated. Okay, the value of the area may be different for both the objects. Yes, it will obviously be different since the radius is different, right? So when you say c1.getArea, you get a different value. So what do you get? You get the c1 circle 1 area is 3.1.14159 something, right? And then when you say circle 2 area, that is 346.36059000 something, right? So both the areas are different. You see that? And why is it possible? Because the properties, the state of that object, which is this property, this radius variable, which is nothing but this radius variable is also called as property. It is also called as attribute. It is also, in programming terms, it is also called as an instance variable. Why it is called an instance variable? Because each instance of the circle has got a different variable value. So for this circle object, the instance variable radius has got value 1. And for this circle object, the radius has got value what? 10.5. Okay, for this particular circle object, the radius is 10.5. Okay, so that's why both the instances have got different properties, or the variables of uh, both the objects are having different values, and that is possible because both the objects have its own copy of instance variable. Okay, each and every individual object has got its own separate copy of the instance variables. Understand? That is why it is called as instance variable, and variable that belongs to each and every instance, individual instance. So if we create 10 circle objects like this, then each circle object will have its own radius. So there will be 10 radius variables in each object. Understand? That is the meaning of an instance variable. But the behavior will be same. The code that is executed, obviously the output may be different depending on the state, depending on the value of this radius, but the behavior will be same. Whenever you call the get area, you will always get the result of this particular expression. Whenever you say get parameter, you will always get the result of this expression. Whenever you say set radius, okay, whenever you say set radius, you will always have to pass some value to it so that you can change the radius. So now see, we have created a circle which was having smaller area. Now we want to change its area. Yes, we can do that. Okay, how can we do that? We can say c1 dot set radius. What new radius would we give? Let's say we give the radius as 5, and then we again check the c1 area. Okay, let's see that what happens. Check this out. Check this out very properly. Circle 1 area is 3.141 dot dot dot. So that is when the radius is what? When the radius is 1. Then you get the area 1. Circle 1 area is 74.539 dot dot dot. That is when the radius is 5. See, and this is circle 2 area which you got because the radius was 10.5. Okay, understand the difference between two? Yes. So you can change the state of a circle to a different state, and how that change of state happens? You simply assign, here the radius was 1, and instead of that, here the radius was assigned a value equal to 5. So you simply change the state of the object by changing its instance variable, and you are able to get a different value in its behavior, in its method. Okay, so that is how objects behave. This is how the objects behave. Okay, so this is circle 1 area, and this same object, same method, but you get a different output because you change the state. Okay, any doubt in this? Please do let me know. This was what? This was about specifically the objects, and that too specifically about its properties, and or simply the state and behavior. Okay, objects have got state and behavior. State is nothing but the instance variable, and behavior is nothing but the method. Okay. So any doubt at all, then please do let me know. Okay, so Jayashankar, did you just saw how I changed the radius values and I got a different output. Yes, you're asking for change the R values, right? So did you just saw that? Okay. So you understood how we can change the state of the object by simply changing the instance variable's value. It's as simple as that. It is nothing but a simple property of the object to which we are assigning a new value, and that's why you are getting a new area, or you are getting a different kind of behavior output. Okay. Okay, fine. So I'll be uploading all this programs onto the repository itself, so you can get it from there. Okay. 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 Now, Jaishankar had one more question. If it didn't take R equal to 1, can compiler take default value? Oh, yes, yes. A very good question, Jay. Let me again share my screen and show it to you what happens. Okay. Okay, the screen is being visible. Okay. So now check this out. If we don't give this radius equal to 1, let me put an empty no argument constructor. This is what? This is an empty no argument constructor, which is equivalent to the constructor that the compiler enters. Compiler also enters this kind of constructor if you don't have any constructor in your class. Okay. Compiler inserts this kind of default constructor. Okay, if there is no constructor in your class. Okay, and the default constructor is an empty. It does not, it has an empty block. It does not have any code. It does not take any argument. Okay. Okay, so now see what happens. This is a, what is this? This radius is what? It is the instance variable. So what happens when you say circle C equal to new circle? What happens? This new circle will create a circle object. Where does it create? It creates in the object heap, right? It creates in the object heap, right? And it creates that circle object saying this is a C and of type circle. Okay, I just underline it and we separate this name with its properties. So here it will have what? Here it will have radius. So see, whenever an object is allocated or anything is allocated a space on the heap, it needs to have some value so that it can determine what space to be allocated to it. So since this is a variable of type double, that much space will be allocated to it, and since the space is allocated to it, by default a default value has been given to it, and that is 0.0. Okay, so now see what happens if we don't assign it any value. Okay, the circle 1 area first time will be 0. Check this out. There it is. You see the difference? The circle 1 area is 0, and then this is circle 1 area, and this is circle 2 area. Okay, so that's it for today. Let's stop the session over here, and if you have any doubt, you can ask. Okay, I hope this doubt has been cleared. Okay, thank you all.